Welcome to Stats with Chaz. I'm Dr. Charlie Collins. Today I will discuss t-tests. More specifically, I will discuss the one sample, paired sample, and independent samples t-tests. I would usually cover each of these in separate videos. However, they are so conceptually similar that I want to cover them together. Which means that this video may be a bit longer than you're used to, so hang tight, take some notes, and bear with me. We'll get through this together. Today I will cover what are the different types of t-tests, what they do, and the steps in calculating them. First, I will cover one sample tests, then independent samples tests. Paired samples tests are so statistically similar to independent samples tests that I will not cover the calculation for those. I will let you know the difference between them conceptually. So, to our first piece. What are t-tests anyway? T-tests examine the effects of a nominal independent variable with two categories on an interval ratio type of dependent variable. In other words, they are comparing relative mean or average differences between two categories on the same dependent variable. Remember, dependent variables are the main variable of interest and are dependent on or influenced by the independent variable. Independent variables, on the other hand, are those variables that do the influencing on the dependent variable. For example, if I were to ask, do students who study have better grades than students who don't? Studying would be my independent variable, and grades would be the dependent variable, which we also call the outcome variable. There are three major conceptual components of t-tests: the independent variable, the dependent variable, and the direction of influence. The direction of influence will be stated in our research question and hypotheses. In my example, I'm making a statement about the direction of influence. I'm hypothesizing that students who study have better grades than those who don't. The direction of influence identifies how the independent variable will influence the dependent variable. So in this case, students who study will have better grades. The emphasis on better is my direction of influence. If I were to say something like their grades are different, I'm not identifying a direction of influence, which is completely okay in t-tests. We just need to make sure that we state that. If all t-tests examine some two-category independent variable on some interval ratio dependent variable and have a direction of influence, what is the conceptual difference between the three types of t-tests? The difference between them is all in the independent variable. Let's look at each test specifically. Keep in mind, these differences are fairly subtle, so keep good notes on this one. First, let's turn to a quick running example. Let's say I'm interested in the dependent variable of class grades for the quarter across different types of people. In this case, my dependent variable is students' grades for the quarter, and my independent variable are the different types of students. Looking toward one sample tests, my research question would be something like, does my stats class have better grades than the population of University of Washington Bothell students? Here, my dependent variable are the average grades, the direction of influence is positive, where my students have better grades than the population, and the groups for the independent variable are my students versus the population of UWB students. These groups are what separates the differences of the t-test, or the different types of t-tests. For the one sample test, we are comparing a sample's mean and standard deviation, or what we call parameters, to the population's mean and standard deviation on the dependent variable of grades. The independent samples test, also known as the two-sample test, also compares two groups on a dependent variable. The difference between an independent samples test and a one sample test is that the independent samples compares the mean and standard deviation of two different samples, as opposed to a sample versus a population, like in the one sample test. So here, I may ask the question, do students in my stats class have better grades than students in my research methods class? Right, so in this case I have two independent samples. Samples from my stats class, samples from my research methods class. Again, all things being similar, a direction of influence, an interval ratio outcome variable, and two groups. The difference is the two groups are comparing samples instead of a sample versus a population, as I mentioned earlier. Finally, let's chat about the paired sample t-test. These are statistically identical to an independent sample t-test, so many textbooks do not cover them. I think they are important, so I'm going to talk about them now. The difference with a paired sample test as opposed to an independent sample test is that a paired sample test is comparing the mean and standard deviation of the same sample over time, or they are comparing people who are quote-unquote paired on some characteristic. For the first example, I may use the research question, do grades for students who use the Quantitative Skills Center increase after using the center? Again, our dependent variable, or our DV, is student grades, our direction of influence increases over time, and our IV is the two groups. In this case, it's a little different because group 1 is time 1 before using the Quantitative Skills Center. Group 2 is time 2 after using the Quantitative Skills Center. You may be saying, well, this is not necessarily two groups, and you'd be right about that, but we treat them as two groups. They are the same people, but comparing them over time, so they statistically function as two different groups. The quote-unquote paired case is a little bit trickier. Again, for the paired test, we're comparing individuals who are quote-unquote paired on some characteristic. Usually this is naturally occurring pairings, such as romantic couples or siblings, for example. For this example, I may ask the question, does the girl in opposite paired twins have better grades than the boy? Again, grades is our outcome, or DV. Direction of influence is better for girls than for boys. And the paired groups are girl versus boy, right? So we have two different groups here still. I know these three types of t-tests can be a little complex, so hopefully I made this clear enough for you. So just to reiterate real quick, t-tests compare means and standard deviations of a two-group independent variable on some interval ratio dependent variable, predicting some direction of influence, or predicting no direction of influence, as long as you predict that. The difference between the three tests is on the independent variable. In the one sample test, we compare a sample versus a population. Those are our two groups. An independent samples test compares two different samples, sample 1 versus sample 2. And a paired sample test compares samples that are quote-unquote paired on some characteristic. Twins, boy twins versus girl twins, for example. Now that we've talked about the three types of t-tests conceptually, meet me in PowerPoint and we'll do some hand calculations. Because of the statistical similarity of each test, I will only calculate the independent samples t-test.